In today's note, we're going to be looking at cosine law. So this is another formula that we can use for non-right angle triangles. So just a quick review from the last note or lesson. We looked at sine law. So I want to try to use sine law for this following triangle. So we can see the ABC, we can see we have two sides and we have an angle, and we're looking for this third side. So knowing our sine law, we would have to make at least one pair with this, right? Because we have the half pair already. With the angle missing the side. Other thing now, we would need a full pair. So it would have to be either this one with A, however we don't have an angle, or this one with C, however we don't have an angle as well. So we can't use sine law with this triangle based on the given information. I can't use any of my trig ratios because it's not a right angle triangle, so I have to use a different law. And that's where cosine law comes in. So just to answer this, we can't use sine law. Because there's not enough information. But we're going to learn today about cosine law, which will be another way that we can solve for sides and angles. So the cosine law is another formula to solve for sides and angles in specifically non-right triangles. And if you see a triangle that doesn't have a right angle, that 90 degrees, you can use cosine law provided there's enough information. Now, this one's a little different from sine law. With sine law, there was only one formula regardless of what we were trying to solve for. Cosine law, there's two formulas. Well, essentially, there's one formula, but we can rearrange it to solve for two different ones. Rather than have you go through and try to rearrange it, I'm just going to give you the two different versions. So one will be if you're trying to find the side length, and one will be if you're trying to find an angle. So for the first example, finding a side length, there are certain requirements that that the triangle has to have, or there has to be certain given information in order to find the side length using cosine law. And that requirement is SAS, side angle side, or what we can call a sandwiched angle. And scroll down here, I'll write the formula up there, but you can see in this box, or sorry, in this triangle, in this example, I have my side, I have my angle, and I have my side. That's what we mean by a sandwiched angle. This angle M sandwiched between these two sides. That means that there is enough information here to use cosine law. And that cosine law formula, a squared is equal to b squared plus c squared minus 2bc times cosine. And that's if I'm solving for side A. If I want to solve for side B, it's the exact same thing. However, it's the exact same thing. The only difference is that I'm going to switch the A, or the angle or the side that I'm trying to find, for B. So now b squared will equal a squared plus c squared minus 2ac times cosine B. And if I'm trying to find that third side, now it becomes c squared equals a squared plus b squared minus 2b times cosine. So you can see it's the exact same formula. The only thing that really changes is the angle has to be paired up with the side that you're looking for. That's why we see big A, big B, little b, big C, little c. The side you're looking for is on the outside, and then everything on the inside are the two sides that you're given. And it doesn't matter which one's which, because based on the operations, the addition and the multiplication, the order doesn't matter. So if I'm looking at this example here, I do have enough information. We've already stated that we have this sandwiched angle, side, angle, side. So I can use my cosine law to find the missing side, which would be m, or little m. Because again, that's the only side that I can find based on this. So we have m squared, or the side that I'm trying to find is equal to, say the other one is L squared plus n squared, so the other two sides, and it doesn't matter which one is which, minus 2 times L times n times cosine of the angle, which has to be paired up sides. So that's how we see this is paired up with big M and little m. Now that I have my formula, I can plug in my missing information. M squared is still the same. I don't know what it is. Side L, based on my triangle, it's 15 squared. Again, it doesn't matter which one's which, really. 12 squared, side N, minus 2 times 15 times 12, and then finally times cosine. Don't forget that multiplied by cosine 60 at the end. For whatever reason, I find students forget to multiply by cosine 60, which will give them a. Now all we have to do is calculate. You could do this all in one step. However, if you're not comfortable with your calculator, I again recommend that you do it one part at a time. Similar to the sine law, how we broke it up by doing the top and the bottom first and then dividing, I'm going to do the same thing here. So everything before the minus sign, I'm going to do first. I'm going to do everything after the minus sign separately, and then I'm going to subtract them. So 15 squared plus 12 squared, 369. Remember that squared means the number times itself, not times 2. For the second part, we have 2 times 15 times 12 times cosine 60, and we get 100. Now we can do a quick calculation. M squared equals, it would be 69, check, 189. So M squared equals 189. Now we're not quite done. We want to find the side length M, not M squared. So what we have to do is we have to do opposite of squaring, which is the square root. Square root is opposite of you may remember this from Pythagorean theorem. We want to square root this. That means M is going to equal the square root of 189. Could get as our final answer 13.7. So that is our missing side length. And that's how you use cosine law to find the missing side length. Other option is if we're trying to find angle. And the requirement for that is that you have SSS, which is side, 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 where basically you have a non-right angled triangle and you're given all three sides. If I look at this example here, triangle XYZ, I have all three sides but no angle. And when we want to do this formula for this, again, it's basically those other formulas rearranged. It's the same thing, except we're just switching it up based on what angle we want. So let's say, for example, I want to find angle A. My formula would be cosine A equal to B squared plus C squared minus A squared, all divided by 2. Trying to find angle B, cosine B is equal to A squared c squared minus b squared divided by 2c, and then cosine c is equal to a squared plus b squared minus c, all divided by 2. So again, it's the same formula. The only thing that's changing is that this angle that you're looking for is paired up with whatever side you're subtracting formula. That's the only real difference. Everything else is the same. Again, the b and the c are the two other sides that aren't paired up with that angle and side, and they can be whichever one based on what operations you have to do. The order doesn't. So in our example here, we have all three sides, so we could solve for any one of these angles. It would just depend on which or how we wrote the formula. I'm going to suggest and just pick one, so we're going to solve for angle y. So if we want to solve for angle y, taking that formula, so that'd be cosine y, that's the angle that we're looking for, is going to equal the two other sides that aren't paired up. So that means x squared, side x, because in x, z, y. Remember, the first two are the sides that aren't paired up. X squared plus z squared minus, now the side that's paired up with that angle, that would be y squared divided by 2 times x times z. And now we're going to plug in our information. So cosine y, we still don't know. X squared is 20, so 20 squared plus 10 squared minus 14 squared divided by 2 times 20 times 10. I'm still going to split it up. You could do this all in one step. I'm going to split it up into these parts, similar to what we've done before, just to make it easier and try to avoid any calculated errors. Top part, 20 squared plus 10 squared minus 14 squared, you get 304 divided by 2 times 20 times 10, 400. And now we should be at something that looks fairly similar to what we did when we were dealing with right angle trig and solving for angle. We had cosine of an angle is equal to a ratio or one number over another number. And it's the same idea when trying to solve in this step. Could simplify this 304 divided by 40 or 400, which I'm going to do that anyways just to make it a little bit simpler. 304 divided by 400, 0.76. The key thing here, you want out of this, when you do your division, your answer should be less than. Anything more than 1 and you have a calculation error somewhere. Right? So it could be you have the sides in the wrong spot, or maybe you did wrong on the calculator. So right now our division, we get 0.76. That's less than 1, so that's good. To get cosine, or to get y by itself, sorry, I have to do the inverse of cosine. Cosine negative 1, 0.76. A little star, inverse, remember that? And on our calculator, we just calculate that. And we get y is equal. That means that angle y is 40. So here we have an example of cosine law for finding sides and finding angles. Again, remember it's for non-right angle triangles. I would always check to see if you can use cosine law first, because it has two specific requirements in can't use cosine law, then you have to use sine law. But for non-right angle triangles, those are your only two options. Sine law or cosine law. Don't have to worry about learning a third one. It's only